Karibu Ibra Network Lab. Hii ni kozi kamili ya Cisco Certified Network Associate. Kupitia kozi hii utajifunza jinsi gani na namna network inavyofanya kazi. Okay, so this is a practical video. As I said in the previous video, we are going to see and learn the fundamental function of the switch. How does the switch use to learn the source MAC address? How does it forward the frame from one device to another device within the same local area network? Now, once we remember, the switch also uses the MAC address to forward the frame from one device to another device. It doesn't know the IP address. So also remember this. Now, from here, our topology tuna PC number 1, PC number 2, PC number 3, then PC number 4. But zote PC hizi zimekuwa connected to only one switch. Now, once you remember, the switch also used to connect device within the same local area network. But also I have assigned IP address to my two desktops. So PC number 1, then PC number 3. I could be able to assign to all these other PC, but I have just only assigned to these two PC just to make the video to be very short and just to understanding. Now, what is going to be done here? Now, let us say PC number 1 is trying to send a ping message to PC number 3. Now, the ping message is contain the IP address. Do you remember in the encapsulation process of the OSI model? Once the PDU is going to be encapsulated from the top layers, then to layer number 4, layer number 3, finally layer number 2, whereby in the layer number 2, the Ethernet, the layer to header and layer to trailer is going to be added together, zinatengeneza a frame. Now within the frame, it contains the Ethernet header. Now the Ethernet header, once you remember in the previous video, it contains different fields. The first field of the Ethernet header is the destination MAC address, then the source MAC address, then the next field is a length or type, then the payload. Now we discussed the payload is the field in the Ethernet header which it contains the actual data ambayo imekuwa encapsulated in the OSI model, which is going to be transmitted katika hiyo Ethernet header from one device to another device. Now, for this video, our payload is going to contain the IP packet. Now, let us begin. Now, when PC number 1 is trying to ping PC number 3, ambazo zimekuwa connected to the same switch and zote zipo katika same local area network. So once you open your CMD of PC number 1 and once you type ping 192.168.10.2, then once you press enter, now the ping message is going to be sent from PC number 1, then to the switch, then finally to PC number 3. But there is a problem. Once you remember, we said the switch doesn't know the IP address. It only understands the MAC address. Now, once also remember, I used to explain the previous video in the Ethernet header, as I said, in any network device, it has its MAC address, and that MAC address, it is unique. Do you remember this? So this PC number 1, it has got its own MAC address ambayo ifanani na PC nyingine yoyote. Also this PC ina MAC address yake ambayo ni unique. Also this PC ina MAC address yake. Also this PC ina MAC address yake. Also the same to this switch ina MAC address yake ambayo ni unique. Now, there is one thing here you're supposed to know, which is ARP. ARP refers to the address resolution protocol. This address resolution protocol, specifically, it was created to map the IP address to MAC address. So the ARP protocol, the main purpose of the ARP, kazi yake ni kufanya mapping ya IP address to a MAC address of that device. So whenever you enter a IP address to this desktop or to any desktop, the desktop, it is going to associate that IP address to its MAC address of that device. So now, the ARP also contain two types of message, which is ARP request pamoja na ARP reply. Now, pay attention here and listen now. Okay, let's begin also the process again. So for the first time, unapoandika katika command line interface, to the CMD ya PC number 1, Then once you type ping 192.168.10.2, then once you press enter, this PC, it is going to associate this IP address to the MAC address, to its MAC address. Now this PC itakwenda kujiuliza itself, do I have or do I know the MAC address of this address ambayo ni 192.168.10.2? If this PC it know the MAC address of this address, the error message it is not going to be generated. Now, where is this PC it is going to search or to look this MAC address ya hii address hapa. It is going to see that MAC address in its ARP cache. So katika ARP cache yake kama haina MAC address ya hii desktop namba 3, basi hii PC namba 1 itakwenda kugenerate the ARP the ARP message. Now, that ARP message it is going to be generated. Now, do you remember in the previous video, in the Ethernet header, the next field after the source MAC address is a length or type. Now, the length or type is the field in katika Ethernet header which it is used to tell what is going to be contained katika payload. Now, do you remember the different type of the field that are contained katika length? Do you remember we used to say 0x0806 and represent that is ARP. Once you see 0x0800 and represent basi the katika payload inakuwa contain the IP version 4. Please, if you don't remember this or if you don't know about this, make sure you preview my previous video of the Ethernet header. I have explained it in depth. Now, since this PC doesn't know the MAC address ya hii PC namba 3, kwa sababu imeangalia katika ARP cache yake haina MAC address ya PC namba 3. Now, it is going to create or generate the ARP message. Now, you remember the type of message ambazo zinakuwa generated katika ARP message? We said there is ARP request pamoja na ARP reply. Now, this PC it is going to send the ARP request. It is going to request the MAC address of PC number 3. Now, the ARP request is going to be sent to the switch for the first time. Now, inapofika sasa kwenye switch, this PC it has got its own MAC address. Now, once the frame is alive to the switch for the first time, the switch it is going to learn the source MAC address of this PC, which is PC number 1. So the switch it is going to use the source MAC address ya hii PC number 1, and then it is going to add it on its MAC address table. Now, after it has already added the MAC address of PC number 1 katika its MAC address table, the next thing it is going to look the frame ambayo imekuwa sent by PC number 1. Now, that frame it is contain the ARP request. Now, the switch it is going to forward that ARP request as a broadcast frame. Now, you remember the broadcast frame we learned in the previous video? The broadcast frame, this is a frame that is going to be forwarded to all over the network device within the same local area network, from one device to many. That is a broadcast frame. Now, for this topology here, the broadcast frame it is going to be forwarded to all over the device except this interface ambapo ime receive hiyo frame. So what is going to be done? So hii PC inapotengeneza hiyo ARP request frame na alive to the switch inakwenda ku add the source MAC address ya PC number 1. Then the switch is going to generate the broadcast frame. That broadcast frame it is contain the ARP message. Now, the broadcast frame itakuwa forwarded to all network device ambazo zimekuwa connected to the same switch except this interface ambayo imepokea hiyo frame. So PC number 2 itapokea hiyo broadcast frame, then PC number 4 itapokea hiyo broadcast frame, then the same to PC number 3 itapokea hiyo broadcast frame. But do you remember in the broadcast frame it was contain the ARP request? Now, that ARP request it is going now to associate it is going to associate the IP address, this one, to its MAC address. Now, that ARP message it is going to now to associate this PC number 3. So the moment hii PC number 3 inapo receive hiyo ARP message, inapo receive your broadcast frame, and within the broadcast frame ina contain your ARP message which is ARP request. Now, that broadcast frame is say who is 192.168.10.2. Tell 192.168.10.1. So by the moment hii PC inapokwenda kuintend hiyo frame ama inapokwenda kureceive hiyo frame, it is going to send a reply message direct to PC number 1, because that frame it says who is 192.168.10.2 till 192.168.10.1. So baada hii frame kuwa received na PC number 3, after ikisha kuwa intended by PC number 3, then this PC number 3 it is going to send its MAC address now direct to PC number 1. So now look here, hizi PC number 4 pamoja na PC number 2 zinakwenda kudiscard hiyo frame kwa sababu the frame it doesn't match to their address. So maybe let's say hii PC tunaipa address ya 192.168.10.3 and hii hapo tunaipa address ya 192.168.10.4. Now the frame ambayo imekuwa generated by the switch which is a broadcast frame, it was contain the ARP request ambayo ARP request it was specific contain this address ambayo ni 192.168.10.2. The aim of this address it was to associate this IP address ambayo imekuwa assigned to which network device kuweza kupata a specific MAC address yake. So hizi devices nyingine za kwenda kudiscard kwa sababu zenyewe sio zenye hii address. Then after hii PC imesha intend hiyo frame, inapojaribu kutuma a reply message which is a ARP reply. Now the ARP reply, this is a unicast frame. Now do you remember the unicast frame? We learned the type of the destination MAC address. Now this frame napo imini hii frame hii PC inapokwenda sasa kutuma reply message, it is going to be sent to the switch. Now since inapotuma a ARP reply, it is sent with its MAC address. Now the switch it is going to add the MAC address now of PC number 3 katika its MAC address table as a destination MAC address. Then it is going to be sent to PC number 1 that MAC address. Then that MAC address inakuwa added katika PC number 1 katika its ARP cache. Then finally the ping message sasa inakuwa sent from this PC direct to PC number 3. Don't worry about this. We are going to see very soon in the next slide in the Cisco packet tracer. Then finally, we are going to see in the GNA3 by using the Wireshark. We are going to capture how this process happened. But what you're supposed to know here is this PC, it is going to generate the ARP request. Then the switch, it is going to generate the broadcast frame, which is contain the FFF, 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 FFF. Then within that broadcast frame, it contains the ARP request. Now, after the PC, which is intended, which is PC number 3, to receive that frame, it is going to intend that frame, then inakwenda kutuma a reply message. That reply message it contain its MAC address. Then the switch itakwenda ku add hiyo MAC address ya PC number 3 katika its MAC address table. Now, the switch it already have the MAC address ya PC number 1 pamoja na PC number 3 in its MAC address table. So now the switch is going to be able now to forward the frame from these two devices direct without broadcast it from any other device, since it already know the destination MAC address pamoja na source MAC address. It has already learned those MAC address na imeshazi add katika its MAC address table. Then finally, these MAC address table ambazo zimekuwa learned by the switch, they are not going to be stored forever. They are just being to stored in the dynamically. So this switch ina learn is MAC address ya hizi PC dynamically, then it is going to store them for the short period of time. So maybe after 5 minutes, then those MAC address tables zinakuwa deleted katika MAC address table ya switch. Now let's get started to the Cisco packet tracer and see this process how it happened. Okay, so here is my Cisco packet tracer topology, and here I have a layer 2 switch, then I have a desktop number 0, number 1, number 2, and number 3. And kila desktop nimeassign IP address. This is .1, this is .2, this is .3, and this is .4. So without wasting time, tunakwenda ku generate a ping message from this desktop number 3 to desktop number 2. But before kabla to generate a ping message, let us have some view katika our layer 2 switch and see its MAC address table, whether if imeshaweza kulearn any MAC address of any network device ambazo zimekuwa connected kwenye hii switch. So you're going to enter the switch, then utaingia katika CLI, then enable the privilege exact mode, then command show MAC address table, then place enter. So unaona hapa katika switch yetu haijaweza kulen any MAC address, so its MAC address table it is empty, and the other name of MAC address table is a CAM table. So whenever you hear a MAC address, it is also known as a CAM table. So hapa tumeweza kuona katika switch yetu haijaweza kulen any MAC address kutoka kwa hizi network device ambazo zimekuwa connected kwake. So let us generate a ping message from this desktop to desktop number 2. So utaingia kwenye hii desktop, then command prompt, then I will type ping 192.168.10.3. Hii ni address ya hii desktop number 2. Okay, so after we have already entered the IP address of desktop number 2 katika command line interface ya desktop number 3, the next thing what we are supposed to do is to shift kutoka katika real time na tuende katika simulation mode. So utaklik hapa katika simulation mode, and then you are supposed to go back to your command line interface ya hii desktop number 3. Then you're supposed to place enter. Then the next thing you're supposed to minimize. Then here we are going to play now and see how this frame is going to be sent from this PC number 3 to PC number 2 via the switch. Now, please be very careful here and watch, and I will explain each step. Now, the first step, now the PC number 3, it is going to send that frame a direct to switch number 0. Now, once you look it here, ukiangalia vizuri, however, there is a dialog box inaonyesha kwamba this frame it is from PC number 3, and the type of address that is contained here, it is ARP. Now, do you remember the ARP? Okay, don't worry, just look here and I'm going to explain. Then it is going to be forwarded to all network device. The device that does not match that IP address, I mean the targeted IP address, they are going to reject that frame. Kama unavyoona zina reject kwa sababu sio targeted IP address. Then finally the intended device, after ikisha intend hiyo broadcast frame, itatuma a unicast frame, then a unicast frame to the switch. After sending the unicast frame from this, because this is a targeted device now, the mono may reply that is a unicast frame from PC number 2 to the switch. Now, this unicast frame, do you remember this is an ARP reply? So an ARP reply, it contains the MAC address ya hii PC number 2. Now the switch, it is going to add that MAC address of PC number 2 in its CAM table or MAC address table. For the first time, ilisha add MAC address ya PC number 3, which is, we are going to see it. So mara kwanza hii PC number 3 ilivyotuma frame direct to the switch, a switch ili use a source MAC address of this PC, add on its MAC address table, then after the broadcast, baada ya switch ku broadcast hile broadcast frame, now this intended device or targeted device, baada ya kutuma reply message which is ARP reply, imetumwa na MAC address yake. So hii switch itakwenda ku add MAC address ya hii PC number 2 in its MAC address table. After then, now this device, they are going to be able to ping now from one device to another device, because the switch tayari inajua source MAC address pamoja na destination MAC address tayari imeshazistore kwenye its MAC address table. So this message which is come back here to PC number 3, this is an ARP reply. So utaona imetuma hapa ARP reply. Now after then, the next thing which is going to be followed is now the next type is ICMP, ambapo sasa ndo ping message inakuwa generated sasa kutoka kwenye PC number 3 to PC number 2. So now the ping is starting working. So hapa inatuma a ping message kutoka PC number 3 then direct to PC number 2, indeed and as expected. Now let us view these fields here. Unaona hapa katika upande wa simulation mode, these are different types of the packet ambazo zimekuwa captured katika upande wa packet tracer. So let us view starting from the first packet to the last packet. Now what was contained in the first packet? The first packet will contain in layer 3. Now, do you remember the layer 3 what is contained? Layer 3 is contain IP address. Now, hapa tuliona to contain the source IP address pamoja destination IP address. Now, let us view here. Let us view here. Now, what is our source IP address? So, ukija hapa katika upande wa outbound, if this is IP header, IP version 4 header. Don't worry about this. I'm going to have a very soon video that I use to explain about IPv4 header. But what you're supposed to know here is the source IP address ni IP address ya hii desktop yetu ambayo ni desktop number. Look, the source IP address ni 192.10.168.10.2. That is the source. So 10.2 hii ndiyo source IP address yetu. The destination IP address ni hii address ya hii desktop number B. Now, the next field ilikuwa ni hii ya ARP. Now let us see here. Unavyoona sasa hapa. So the ARP message it was generated. Now, angalia hapa vizuri. This field is Ethernet header. Do you remember the Ethernet header we learned? It was contained the preamble, the SFD, pamoja the destination MAC address, the source MAC address, the type, the payload, pamoja na frame check sequence. Now, the preamble pamoja na start frame delimiter, these are not included as a part of the Ethernet header. Hope we remember. Now, the next field is a destination MAC address, which is FFFF, :FFFF, :FFFF. Now, do you remember what is this MAC address called? This is a broadcast MAC address. Now, the next field is a source MAC address. The source MAC address hii ni MAC address ya hii PC number 3. So ukiangalia vizuri hapa, hii ni MAC address ya hii PC number 3. As I said before, kama nilivyosema before, for the first time hii PC inapotengeneza hiyo frame, inapokuja katika switch, a switch it is going to use a source MAC address na kuadi katika its MAC address table. Then after ikisha add katika its MAC address table, then itakwenda generate a broadcast frame. After generate a broadcast frame, ishakuwa flooded. Now the device that is targeted baada ya kutuma the ARP reply, now the switch is going to use the ARP reply to add the MAC address of targeted device. So as you can see here, ilikuwa ni now outbound PDU. Now this source MAC address ndilikuwa address ya hii desktop number 3. Now the next field is a type or length. Now do you remember the type or length in the Ethernet header? This field inatumika kutuambia what is actual contained katika a payload. Now once you see here, however inaonyesha hapa the type is 0x0806. 0x0806 and represent this is the ARP message. Now the ARP message it is what now contained katika katika payload of this Ethernet header. And that's all for about this, the next field. Now field iliyofuata ni katika switch. Ilipofika katika switch, now still more the switch ikatengeneza broadcast frame, kuflood hiyo kutengeneza hiyo broadcast frame, then ika flood to all network device. Then still more ilikuwa ni ARP message. Now let us see after the reply now kutoka kwenye PC number 2. Now PC number 2 ilijibu kwa kutuma sasa umeona hapa the destination MAC address now it has changed. The destination MAC address here imekuwa ni MAC address ya PC number 2, then the source MAC address sasa ndiyo MAC address ya hii PC number 3, then the type also this is 0x0806, which means hii ndiyo ARP reply ambayo imekuwa generated na PC number 2 ambayo ilikuwa ni targeted. So the switch itakwenda kutumia hii destination MAC address kuweza kuadi katika its MAC address table. Now let us see the MAC address of the switch, how was that added. So nitarudi hapa katika real time mode, then nitakuja katika upande wa CLI my switch, then nitaingia katika privilege exact mode, then nita show MAC address table. So unanionyesha hapa kwamba hii switch imeweza kulearn two MAC address. The first MAC address it is 009.2b5e.8426. This was learned dynamically via fast Ethernet 04. So now FA04 ni hii hapa interface ya fast Ethernet 04. So this internet interface FA04 imekuwa connected direct to PC number 3. So the switch used to learn MAC address for the first time of this PC via hii interface ya fast Ethernet 04. Then ikaja pia ikalearn another MAC address ambayo ni 00D or .ff.5c.2d.10 pia lilen dynamically via interface fast ethernet 0/3. So fast ethernet 0/3 ni hii interface ambayo imekuwa connected direct kwenye hii PC number 2. So iliweza kulen vipi? Baada ya hii PC number 2 kuweza kutuma an ARP reply message. So an ARP reply message, this PC was sent its MAC address to this from the requested ARP message ambayo ilikuwa sent by PC number 3 kuweza kuassociate its IP address to its MAC address ili sasa iweze kumping na kuweza kujua hiyo MAC address yake. So remember the switch, kwa nini imefanya hivyo? Kwa sababu hii switch doesn't know the IP address. So ilichokifanya hii meaning the ARP message imekwenda kuassociate the IP address to the MAC address. Baada ya kujua MAC address ya hiyo PC, umeona for the first time, baada ya ARP reply na ARP request kufanyika, now the next step ilikuja sasa ndiyo ICMP. So the ICMP now was be able to be sent via the switch, kwa sababu the switch it has already know the MAC address of these two devices ambazo zinajaribu kutumiana hizo, I mean hiyo ICMP. Okay, so now I'm hopeful you have understand the fundamental function of the switch. So for the switch iweze kuforward the frame kutoka device moja kwenda device nyingine, it's supposed first to know the MAC address of those devices. So the device that is going to send the frame to the switch for the first time, so the switch itakwenda kutumia hiyo interface ambayo imetumwa kupokea hiyo frame, ita add kama a source MAC address, then inayotakiwa kumfikia sasa before kabla haijawa flooded, itaangalia kama inayo MAC address ya hiyo device kwenye MAC address table yake, basi ita forward direct. Kama haina MAC address ya hiyo targeted device, so for the first time itatengeneza hiyo ARP message, then itakuwa forwarded to all network device ili kuweza ku associate meaning the IP address to the MAC address of that device,